Unreactivity of alkane due to strong sigma bond and its saturation cause it to have only two types of reaction, which are combustion and substitution. Alkanes are often burned as fuel to generate electricity, heat homes and cook food, provide energy for industrial processes, and also to provide power for transportation. In presence of excess oxygen, alkane combust to form carbon dioxide, greenhouse gas, and water. However, in limited supply of oxygen such as in closed room, alkane burn to produce hazardous carbon monoxide and water. In a very limited supply of oxygen, alkane only produce carbon and water when combusted. One of the hydrogen in alkane is substituted by halogen to produce halogenoalkane in substitution reaction. Since alkane is unreactive, this reaction will only occur in the presence of sunlight. This reaction is mostly referred as free radical substitution reaction. From the name suggests, this reaction involves radical which obtained from homolytic fission. Free radical substitution reaction has three steps: initiation, propagation, and termination. In the first step, the free radical will be formed. In propagation step, it is a chain reaction. And in termination step, where the two free radicals will react together to form molecules. Example 1. Reaction of methane with chlorine in sunlight. This reaction will produce chloromethane and hydrogen chloride as stated in the balance equation below. So let's go into the mechanism on how this reaction proceeds. In step 1, in the presence of sunlight, the chlorine molecule will undergo homolytic fission to produce chlorine radicals. Make sure you use fishhook arrow to show this fission. And any radicals are very reactive. Hence, the first step in propagation process, the chlorine radical will attack a methane molecule, which make one of the CH bond in methane to undergo homolytic fission to form methyl radical and hydrogen chloride. The hydrogen and chlorine radical will then combine to form hydrogen chloride. This is the methyl radical. In second step of this chain reaction, the methyl radical, being very reactive, will attack another chlorine molecule, which cause the chlorine molecule to homolytic fission. One of the chlorine radical formed will bond with methyl radical to form the product chloromethane and another chlorine radical. So this chlorine radical will then attack another methane molecule as in the first step. Then continue with the second step. So this reaction continue as a chain reaction up until all of the radicals combine with one another in termination step. The propagation process is finally come to an end when any two radicals collide and bonded to one another in termination step. The possibility could be both chlorine radicals combine to form chlorine molecule, methyl radical and chlorine radical combine to form chloromethane, and both methyl radicals combine to form ethane molecule. This is the summary of the reaction. Let's go to it together again. In initiation process, chlorine molecule will undergo homolytic fission in the presence of sunlight to form chlorine radicals. So this radical being very reactive, it will attack another molecule to form hydrogen chloride and methyl radical. This methyl radical will attack another molecule, in this case chlorine, to form chloromethane and chlorine radical. This process will continue up until the two radicals collide and combine with one another. So the possibility could be chlorine radical with chlorine radical to form chlorine, or chlorine radical with methyl radical to form chloromethane, and methyl radical combined with methyl radical to form ethane. So ethane is a byproduct or minor product of this reaction. Another example, reaction of ethane with bromine in sunlight. This reaction will produce a major product of 1-bromoethane and hydrogen bromide. So let's get into the first step, initiation. So in the presence of sunlight, bromine will undergo homolytic fission to form bromine radical. So in propagation step, the bromine radical will attack ethane to form hydrogen bromide and ethyl radical. This ethyl radical will attack bromine molecule to form the product 1-bromoethane and bromine radical. So this process continues up until in termination step. So we have either bromine radical combined with bromine radical to form bromine, or we can have ethyl radical combined with bromine radical to form 1-bromoethane, or ethyl radical combined with another ethyl radical to form butane. And butane is the byproduct or minor product of this reaction. Now you might be wondering, once the product formed, can't the radical attack it and undergo more substitution? Yep, it could happen. But this reaction has a lot of things to consider, such as bond enthalpy, and only produce in a very small amount. Hence, we will disregard this type of reaction, and it is not in your syllabus.